This is question from May, June 22, variant 32, 970-932. Question number 4. The equation of the curve is y equals to cos cube x into under root of square root of sine of x. It is given that the curve has one stationary point in the interval from 0 to pi over 2. X is greater than 0, less than 1 over 2 pi. Find the x coordinate. Find the x coordinate of the stationary point. Find the x coordinate of the stationary point, giving your answer in correct to three significant figures. So here you can solve this question by the product rule, because for the stationary point we know that dy over dx is equals to 0 for the stationary point. So you're given y, so cos cube of x into square root of sine of x. So instead of using the product rule, instead of differentiating it directly, so you can make the situation simpler. Uh, like if you take log on both sides, this is a special technique. So product rule is one method. The alternative method is that you take log on both the sides and make implicit equation. So taking log, natural log of y is equals to natural log of cos cube of x into square root of sine of x. Now recall the properties of the log. Natural log, so if there is a product, you can write natural log cos cube x plus natural log of square root of sine of x, or you may write sine of x power 1 over 2. Now again recall the power property of the log. So this power, which is 3, can be shifted here, and this 1 over 2 can be written here. So you can write it as the next step 3 natural log cos of x plus half natural log. So we have in this way implicit equation, and we can differentiate this implicit equation for dy by dx. So here write down a statement, differentiate the implicit equation. So left hand side is natural log of y, the differentiation of natural log of y, natural log of y. So we have the formula, like if there is a natural log of d by, like if you can do it like this, if there is y equals to natural log of fx, its differentiation is dy by dx 1 over fx into f dash of x. This is the formula for the differentiation of natural log of any function. So left hand side is natural log of y. You can write natural log of y as 1 over y, and for y the differentiation with respect to x is dy over dx. So I'm differentiating this with respect to x. Right hand side is 3 natural log of cos of x. So it is 1 over cos of x, the differentiation into the differentiation of cos, like f dash is there. Differentiation of cos we know is minus sine of x plus 1 over 2. Natural log of sine of x is 1 over sine of differentiation, and differentiation of sine is cos. So don't forget to multiply by cos. So here, as we are looking for the stationary point, and for the stationary point, the x coordinate of the stationary point dy by dx is equal to 0. So here at this stage, put dy over dx equals to 0. This I'm doing for the stationary point. So if dy by dx equals to 0, obviously on the left hand side it is 0. Right hand side can be simplified, and you can write minus 3. We have sine over cos. Sine over cos is tan of x plus 1 over 2 half. So cos over sine is cot, or you may write cot, or you may write tan of x in the denominator. Because cos of x over sine of x is cot, or is equals to 1 over tan of x. Now, simplify 3, or you take LCM, or you shift 3 tan of x here, is equals to 1 over 2 tan of x. So we're looking for the x coordinate of the station point, and yes, this is there. 3 tan square of x is equals to 1 over 2, or you may write 1 over 6 directly. And from here, tan of x is equals to plus minus 1 over root 6. As we're looking for the values of x from 0 to 0 to pi over 2 means the first quadrant. So here you take tan of x is equals to 1 over root 6, and tan of x is positive in the first quadrant, and in the next quadrant, as we are looking for the answer from 0 to pi over 2, so only consider the first quadrant. So ignore the negative value of tan of x. So here we have tan of x is equals to, because we know that tan is negative, tan of x is equals to minus 1 over root 6. Tan is negative in these two quadrants. So this is not the case here, because we are looking for the answer from 0 to pi over 2. Just ignore this part, and from tan equals to 1 over 6 under root, you may find the answer. So draw the quadrant diagram, write the basic angle. This basic angle is tan inverse of 1 over root 6. Tan inverse of 1 over root 6. So on the radian mode, don't forget to change your calculator to the radian mode. So we have the radian mode of the calculator, and on the radian mode of the calculator, the basic angle is coming as 1 over root 6 inverse tan 0.387675, so on. So this is the basic angle, and so the answer for x, this is the answer 0.388. So the value of x, so this is that value of x for which there is a station point. Find the x coordinate of the station point was the question, and here is the x coordinate of the station point, and this basic angle was 0.38759, and so the answer is 0.388. Thank you.